Okay, so today we're going to be talking about changes of state. Now, matter can be changed from state to state without changing its identity. Now, there are 6 ways matter can change. The first one is melting, that we all know, which is it changes from solid to liquid, like when your ice melts into liquid water. Then we have freezing, which is changes from liquid to solid, and that's when if you want to freeze liquid water to become ice, that's freezing. Then we have evaporation, so changes from a liquid to a gas. Let's say you're cooking ramen one day and you're boiling water, and then all of a sudden that steam starts to produce. Well, that's evaporation because the liquid water is becoming steam, that gas water, that gas H2O. Then we have condensation, which is changes from a gas to a liquid. Now, if you take out a cold water bottle out in the summertime, you're going to start seeing droplets or water, liquid water outside of the water bottle. That is what's going on is condensation because it's the vapor, the water gas in the air becoming liquid onto your bottle. And then 5, you might not have heard this before, but this is sublimation. This is changes from a solid to a gas. So if you've ever been to an ice cream parlor and they open up those freezers and there's that white smoke coming out of it, that is actually dry ice going immediately into a gas form. So that's dry ice is solid H2O, CO2, and when it is exposed to air, room temperature, it will go automatically to that CO2 gas. Then the opposite of that would be deposition, which changes from a gas to a solid. Now, during a change of matter, there is a temperature change in which heat causes the change by adding or removing energy. So we talked to you a little bit the other day about temperature, meaning that's how fast or slow particles are moving in a substance. And it kind of correlates with heat because heat is an energy. So if the temperature is going up, that means heat energy is being added. Or if temperature is going down, that heat energy is being removed. So with that, all of this can be represented through a phase change diagram.
So, phase change diagram of water. Now, the melting point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. Let's draw the phase change diagram for water. So right now we have a chart. On our y-axis, we have temperature in degrees Celsius, and our x-axis is we have time. So time is increasing from left to right, and temperature is increasing from down up. As you can see, we have a diagonal line, a straight line, a diagonal line, a straight line, and a diagonal line. So let's see where we're going to put the melting point and where we're going to put the boiling point of water on this diagram. We know that they're going to go on our y-axis. Where specifically on our y-axis? Well, 0 is going to go there. Now 0 we know is that melting point. The melting point is always going to line up to our first straight line. I'll tell you why that is in a minute. Then our 100 degrees Celsius is going to line up with our second straight line, and 100 degrees Celsius is our boiling point. So now let's talk about what this first diagonal line represents. Well, this represents the solid. So if you go up or if you go down, this diagonal represents the solid phase. So whatever temperature here until it gets to 0 degrees Celsius, water is always going to be a solid. Now, from 0 degrees Celsius all the way to 100 degrees Celsius, water is always going to be a liquid. And then when you go from 100 degrees Celsius all the way up to whatever temperature you want, water is always going to be in the gas phase. So these diagonal lines represent the states of matter. So I'm at this point right now, and I'm going to go to a liquid. Well, this straight line at 0 degrees Celsius represents a phase change. So from left to right, that solid is being melted to become liquid. At 0 degrees Celsius, the water is melting. Oppositely, it could also be freezing as well. Now at 0 degrees Celsius, water can be evaporating, there's evaporation, or it can be condensing. So these straight lines represent a phase change. We also know that we have sublimation, goes from a solid to a gas, and we have deposition, which goes from a gas to a solid as well. Okay. So in the last slide, we kind of talked about temperature change, energy, all that stuff. So we know that temperature is increasing as we go up. So as we continue up our diagram from left to right, our temperature is increasing because it's going up. That means energy is added. And when energy is adding, there's heating. There's heating going on, and that's why temperature is increasing. Now let's say I start from gas going down, 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 down. There's going to be a temperature decrease. If there's a temperature decrease, energy is removed, so there's a cooling going down. The temperature is decreasing. There's a cooling going down. Okay. Now, let's do a phase change from another substance. Oh, before we do that, so as temperature increases, the particles speed up, the particle speed increases and are spaced out more. So as that energy is being added, as the temperature is increasing, the particles are moving faster, so they're becoming more spaced out, right? We still see that in that solid liquid gas diagram. And looking oppositely, as the temperature decreases, the particles' speed decreases and are becoming closer together. So as that temperature decreases, that energy is being removed, particles are moving slower, and the particles are becoming more together at the end, as we can see when we go down from solid, liquid, and gases. All right, so let's do a phase change diagram of another substance. We have ethanol. The melting point of ethanol is negative 14.5 degrees Celsius. The boiling point of ethanol is 78.5 degrees Celsius. So let's try the phase change diagram of ethanol. Well, we always put our melting point first and then our boiling point. And we're always going to start with our diagonal until we get to that melting point. Then we do a straight line at our melting point, diagonal till our boiling point, straight line at our boiling point, and then diagonal. And that's all you do. So let me know if you have any questions after watching this. Other than that, I do have a homework assignment posted up on Google Classroom, and that will be due Wednesday, so 2 days from now. All right, see you guys. Thanks.